Yeah, I can see the screen now. That's good.
Okay, so what would you get if you expanded the first one, part A?
So x plus 4 squared equals x squared plus 8x plus 16.
And how about B?
X minus 9 squared. That would be x squared minus 18x plus 81 plus 81.
And okay, I think it'd be fine for that.
Yeah.
Hang on. Which one of these square brackets will expand to give you a 2x as the x term?
The x plus 1 squared.
Yeah. X plus 6 squared, that would give you what x term?
That would be x. That would be 12x.
Yeah. Okay, so a perfect square is when it's just one bracket squared. This one here, x plus 3 squared plus 1, that's not a perfect square because it's not one bracket squared. So for all of these, perfect square or not perfect square, left or right?
So x plus 5 squared is a perfect square.
Mm-hmm.
X plus 5 squared plus 3 is not a perfect squared. Not a perfect square. And the same for x minus 1 squared plus 2 minus 11. And then that's a perfect square. X minus. And that one isn't a perfect square. That one is not a perfect square. And the last one is a perfect square.
That's it. Let's see. Yes, so if b over 2 squared is equal to c, then it can be written as a perfect square. And so for this here, x squared minus 20x plus 100, will that become a perfect square or not? So what would be b over 2 squared for that?
So for quadratics, when a is 1, b over 2 squared is c, then it can be written as a perfect square. Okay, so the b term is then, so for the first one it's 20 minus 20. So minus 20 over 2 squared is 100. So then that is a perfect square, yeah.
Yeah. And how about the other one?
What's that one? So so x squared plus 6x. Okay, so that one. So if we assume it is a perfect square, so 6 over 2 squared gives us 9, but that's not 10, so it's not a perfect square.
That's it. Okay, so that's not a perfect square. So these, perfect square or not a perfect square? And you might be able to do it in your head.
Yeah, so the first one, that's 10x, so 10 over 2 is 5. Yeah, that's a perfect square. 6 over 2 is 3 squared. That's not a perfect square. Minus 2 over 2 is 1. No, that's not a perfect square. That is a perfect square. That one is also a perfect square. That one is not a perfect square.
Mm-hmm.
And that one is...
These are okay. We're fine there.
Yeah.
So this one, if you have a minus c, then it can never be a perfect square because it's squared. So what would you... So change one thing to make each of these a perfect square.
Okay, so if we want the b term to be... So b over 2, that's 3. So we could change the last number to a 9.
Yeah.
And then for the next one, we could change minus 2. We could change the c term to a 1.
Yeah.
And for the next one, so that's 5. We could have it as a plus 25 rather than a minus.
Yeah.
And the last one, we could have it as then 4 squared is 16, so plus 16 instead of 100.
Or what if you kept it as 100? What would you change the 8 to?
If I kept that as 100, you change the 8 to b over 2. So b over 2 squared is 100. So then b over 2 should be 10, and then b would be 5 then.
B over 2 equals 10?
Oh, sorry, yeah, that would be 20 then for b.
That's it. So you could make C 16 or B 20. Okay.
Yeah.
I think you're going to be fine for those. What would be E for this?
So x plus 1 squared plus 7 equals, so that would be x squared plus 2x plus 1 plus 7, which equals x squared plus 2x plus 8.
Okay. And those are trickier, but I think you'll be fine there. Let's do the very last one.
Okay. So x minus 7 squared minus 49 is x squared minus 14x plus 49. Yeah, so that would be x squared minus 14x. That's it.
Yeah, that's right. X squared minus 14x. So the minus 49 got rid of the plus 49. Okay, so this one here. What would this be in perfect square form?
X plus 3 squared.
Yeah. And any idea how you can use that? What is part B in this form?
X squared plus 6x in the form x plus 1. Okay, so that will be x squared plus 3, x plus 3 squared.
Mm-hmm.
And then that would be 9. So 6. Is it plus? I'm not too sure. What would you do for that one?
So what's the difference between A and B?
There's no. Oh, so you minus 9 from that to get rid of the C. Okay, that makes sense.
Yeah. Okay. How would C plus 5?
Plus 5. So x squared plus 6x plus 5. So then we minus 4 instead. So x squared, x plus 3 squared minus 4.
That's it. Okay, and then sketch the graph. We don't need to do that, I don't believe. And I'll just look at the exam questions to make sure. Yeah, so basically, so that's called completed square form. So these two here are, so the first one is a perfect square, and then the second and third are completed square form, where you've got a perfect square and then a bit extra added or subtracted. Often it is subtracted. Okay, same idea. Let's try this.
X minus 4x squared form plus p squared plus q. So then if we were to write x is x minus x. So x minus 7 squared minus 49.
Yep. And I think you'll be fine for the rest there. Okay, so to write in completed square form, first you make the perfect square. So this one here, x squared minus 8x. X squared becomes x, minus stays the same, and it's b over 2. So instead of 8x, it's now 4. So you divide by 2x. Basically, you remove the x and half it. That's in a perfect square. You then have to, so to get rid of the extra 4 squared, you have to do minus 4 squared.
Okay.
And then just remember to add in the 3 that was there in the beginning.
Okay, that's fine. Could I copy that down as well, if that's all right?
Yeah. So basically make the perfect square, complete the square, and then simplify.
Yeah. Okay, yeah, thank you. Got that.
Okay. Okay, so write these in completed square form.
Okay, so 5a is x plus 4x squared. Okay, so x squared plus 5. So that would be x plus 2 squared minus 2 squared plus 5, which equals x plus 2 squared plus 1.
That's it, and you'll be okay for the other two. Write these as perfect squares. I think it'll be fine. Write that in completed square form. I think you will be fine. That's another way of thinking of it as completed square form. That's fine. I think you'll be fine for all those. Okay, well, let's just do the very last one, E.
Okay, so x squared minus 4. So that would be x minus 2 squared plus 2.
2 squared minus 4 plus 6 plus 2. Yep. Okay. I can write quadratics in the form x squared plus bx plus c in completed square form.
I think that's a tick, yeah.
Yeah. Okay. This one, simplify these surds. What would be the first one? Any idea? Do you already know how you simplify a surd?
Yeah, I think we did this once, so I'll just write them down. So root 45 is root of 9 times 5.
Yeah.
Is 3 root 5.
Yep, that's it. 3 root 5. So that's just a bit of revision. That's fine. Okay, solve each of these. Let's do these two.
Okay. A and C. Okay, so
A and B, sorry. A and B.
okay, right. Okay. So x minus 1 is plus or minus root 3.
Nah. Let's make it difficult, sorry. B and D. We'll do B and D.
Okay, yeah. So, okay. B plus 2 squared is plus or minus root 2. Okay. So x equals plus or minus root 2 minus 2.
Yep. And that's fine. And
okay.
D?
All right, okay. So
because they said give your answer in surd form. That's a surd.
So D is in x minus 4. Plus 1. So then x equals plus or minus root 3 minus 3.
3. So how do you bring the minus 4 to the other side?
Oh, you add 4. Oh, yeah, sorry. So that should be plus 5.
That's it. Okay. So now you have to use completing the square to solve an equation. So first write it in completed square form, and then once it's in that form, try to solve it.
Okay, so x plus. Okay, so then x plus 2 squared minus 2 squared plus 1 equals 0. So x plus 2 squared minus 3 equals 0. So x plus 2 squared equals 3. So then x plus 2 is root of 3. And then x is, plus or minus root 3, because, yeah. So then x equals plus or minus root 3 minus 2.
That's it. Minus 2 minus root 3, or minus 2 plus root 3. Got it. Okay, so, and that's an exact answer because it's third form. These ones, I don't think it's any more difficult. How would you solve b by completing the square?
Okay, so for b, we need that in a third form. No, in a like ax squared plus bx plus c form. So x squared plus 4x minus 8 equals 0. Is 0. So x plus 2 squared in a bracket minus 2 squared minus 8 equals 0. So x plus 2 squared minus 4 minus 8 minus 16.
Minus 2 squared?
Has the...
What is minus 2 squared? Hello, Stefan?
Hello, sorry, the call ended, I think.
Okay, I could still see you and hear you.
Okay.
Okay, so this one wasn't minus 16. What would it be?
Yeah, so x squared, so that's minus 4 minus 8, so that's minus 12.
Yeah.
Yeah. So x plus 2 squared equals 12. And then x plus 2 is root 12 plus or minus root 12. And then x is plus or minus root 12 minus 2.
That's fine. Okay. What if they wanted that to 3 decimal places or something?
You just find the root of 12 and then you minus 2 from that, and then you have a solution.
And how would you get the two different answers for the plus or minus?
You just, for the first answer, you just negate the... So if you just find root 12 and then you negate that, then you can get minus...
Okay. Okay, yeah. And another way to do it might be a more direct way. If you just put in the minus before, so minus root 12, press right, minus 2. And that way you'll just get it in one go. So I'll say, yeah. What was I going to say? So, okay, that's fine. They have a weird way, I think, of putting the minus after it. I'm just kind of careful. So I always put the number first and then the square root second, just in case. Because some people will say root 12 minus 2 equals root 10. And they'll kind of just forget, that way.
Yeah, yeah.
Whereas if you put the number at the front, that doesn't happen. But that's just me. Okay, I can solve quadratics by completing the square.
I think that's a tick. I got that. It's fine.
Okay, so now the good stuff. So now it's not 1x squared, it's now ax squared. So it could be 2, 3, 4. So you first do this by factorizing out the 3 from the first two, and then you go from there.
Right, okay. Yeah, okay. So then... Okay, that's a bit... Yeah, okay. So 3x squared minus 12x minus 1 is... So then if we have 3 outside the bracket, that's 3 and then x squared minus 4x minus a third.
You only need to factorize for the first two.
Oh, right. Okay, so yeah, okay, so then... Okay, yeah, minus 1 there, okay. Minus So that is okay. So that equals.
And now you complete the square for that bracket.
Okay, so.
And if it helps, just ignore everything else and just complete the square as though you were doing that all by itself.
Okay. Yeah, I think I got that. So that would be then 3, and then a square bracket, and then a little bracket. X minus 2 squared minus 2 squared minus 1.
And where is the -1 in terms of the square bracket?
I think it's outside the square bracket.
That's right. -1. And then any idea how you get rid of the square bracket?
No.
So basically you expand the square bracket out by multiplying by 3. And you just multiply the square bracket by 3, but you don't bother expanding the whole bracket.
Okay. Oh, right, I get that. So then that will be just 3 outside the bracket.
Yeah.
So then that will be then 3x minus 2 squared minus 4 minus 12 minus 1.
That's it. And so final answer?
So 3x minus 2 squared equals 13.
And yeah, we're not solving this one. It's just.
Right.
Yeah, so we don't need to solve it. Okay, any questions about that one?
I think I got that. But could you just write this? Because last time there was like a sort of step-to-step way to do it. Is that all right if you could like?
Yeah. So it's very similar to the previous one. So I think I have a kind of a strange way of doing it. I don't think it would be good for you because you were good at doing that. Most people aren't. And so I kind of tell them, ignore the 3, ignore the -1, just do that. Then bring back in the 3, expand it, and then just bring in the number at the end. So I think you can just do them all at once. Okay, so step 1 is factorize out A. Factorize out A from the x squared and x terms.
Okay.
And not the c term, if you like. Step 2 is complete the square. And that's for the x squared and x term, but that's always true.
Okay.
So you basically just complete the square. Complete the square, and I'll just write in using square brackets.
Okay, yeah.
Using square brackets. Step 3, expand the square bracket only. So you don't expand the expand the square brackets. So you don't expand the perfect square.
Okay.
Expand the square brackets only, I should say. And then I think 4 would be simplify. And is it worth putting in a note that? No, I think, yeah, expand the square bracket only. So then you're not expanding the double bracket. And so it's just the 3 or whatever it is goes at the front.
Okay, yeah.
Yeah, so factorize out A from the first 2 terms. Complete the square using square brackets. So basically you're going to get double brackets. Expand the square brackets only and then simplify. And that simplify required 3 times -2 squared minus 1.
Okay.
Okay, and so this is generally what it looks like. This is kind of, I think, not a very helpful way of looking at it, but this is it. So you factorize out the A. So then it becomes 1x squared, which we know how to do. That becomes b over ax. So basically you just do completely the square as normal, and then you've got the extra plus c at the end.
Okay.
So let's practice that one. Let's try this first one, A.
Yeah, so with that previous like model that they shown, like with the that one. Do we need to? I think is that the same as what we just did now, or I didn't really get that
So
actually.
this isn't very helpful. This is basically just in factorized form. So
Okay,
it's not even in completed square form. That's just factorized form. So I think you're okay. I think it's easier for you to just factorize out 2 or factorize out 3 than it is to think about it in that way.
okay, yeah.
I just include that because it's in the book. Okay, so write these in completed square form.
Okay, so 2x squared plus 12x plus 2 equals, so we have then, so 3, no, so that'll be 2, and then x squared plus 6x,
Mm-hmm.
and then plus 2, plus 6x. Plus 2 outside the bracket. And that equals 2, and then like a square bracket, and then x plus 3 in a smaller bracket squared, minus 3 squared, plus 2, I think.
And where do I close the square bracket?
Just after the minus 3 squared.
Yeah.
So then, okay, so so then that would be 2 outside of to get rid of the square bracket, that's just 2, and then x plus 3 squared, like in the smaller bracket, minus 18 plus 2, which is 2x plus 3 squared, minus 16.
That's any questions there?
I think I got that now, that's great.
And I think you'll be able to do all of those now.
Okay.
Okay, x a half a tick, ax squared plus bx plus c in completed square form.
I think that's a tick, yeah, I got that.
Okay, and then we might as well do one where we solve it. Let me just check. So these are solving. Okay, let's do this exam question, so you have to solve it.
Okay, so solve 6x squared minus 3x minus 13. Give the 2 dp. So I think that needs a whole, like a number. So, okay, so 6x squared plus 3x 0. So that would be 6 outside a bracket, and then x squared plus 3x, and then close a bracket, minus 13.
If you factorize out the 6, then the 3x would become...
Oh, yeah, that would be half x, isn't it?
Yeah.
Sorry. Okay, so half x. Yeah, I got that. Yeah. So, so then 6 and then a square bracket, and then x plus a quarter x, I think, squared.
Hold on. So, if you were to expand this square bracket, sorry, so we now made a square bracket, and so if you were to, well, if it was x plus a quarter x, that would be 5 quarters x. So what should it be?
So 5.
So I'm not sure if you just misspoke. Basically, it's just x plus a quarter, and you don't put in the x again. It's
yes. Yeah. Sorry about that. Yeah.
It's okay.
So then x plus a quarter squared, minus 13. Oh no. Minus a quarter squared, and then close the square bracket, minus 13.
Yeah.
So that is so x. Yeah. So that is. Then we just remove the square bracket, so then that would be 6x. So 6 and then x plus a quarter squared minus 6 over 4, which is, I'll just have it as minus 6 over 4.
Is that what you get when you do minus 1 over 16 minus 13?
Oh no, wait. 1 over 6. Oh yeah, because it's squared, isn't it? So I'll just type that in the calculator.
Okay.
1 over 16 minus 13 is 6. That would it be minus 7 because it's 6? Because you multiply the minus a quarter squared by 6, so I got minus 7 for that. So
Oh, I'm sorry. You're absolutely right. You multiply it by 6. Sorry. So it's minus 6 over.
minus, wait, yeah, so minus 6 over 4 squared.
Yes.
Which,
yeah.
And then we minus 13 from that, so
that's it.
Minus 6 over 4. Squared, yep. So then minus 13 is minus 43 over 4.
Okay.
So 4. So that is, yeah, I think that's all you have to do, isn't it? So it's
yeah, and now you go about solving it.
Okay, so, all right, okay, so, yeah, so 6x plus a quarter squared equals minus 43 over 4.
And if it's minus, is it negative? It's negative on the left side, isn't it?
Yeah.
And so it would be equal to when you bring it to the other side?
Oh, yeah, so that'll be 43 over 4. Okay.
Yeah.
Yeah, so then we multiply divide both sides by 6, so that'll be x plus a quarter squared equals 43 over 6 times 4, which is 24.
Mm-hmm.
So, and then x plus a quarter is root plus or minus root of 43 over 24.
Mm-hmm.
So, yeah, so then x is plus or minus root 43 over 24 minus a quarter.
That's it.
Or if you want it the other way around, I could do it. So minus a quarter plus or minus.
Yeah, I mean, you don't have to. It's just, I do it just to make sure I don't make a mistake.
Okay.
Yes, so how would you get that to 2 decimal places?
So you just type that in the calculator. So, and then get the number and then round that to 2dp.
And how many answers would you get?
Oh, you'd get 2 because you got a minus root as well to deal with.
That's right. And so, yeah, and you just put in the calculator and you get the answer. Okay, any questions there?
No, I think I got that. That's fine.
Okay, so I just want to see. So I can solve all quadratics by completing the square. X a half or tick.
I think that's a tick. Yeah, I got that.
Okay. Let me just see this thing. Oh yeah, so this is a slightly different thing, but it's parameter. Okay, x squared equals 9. What is x?
3.
Anything else?
Or minus 3, yeah.
Correct. So that's plus or minus 3. So the x squared equals 0. What is x?
I don't think that's really a number, but in theory it would be root x, wouldn't root 0. So
okay. What squared gives you 0?
No, 0 squared.
Yeah, and so actually the answer is just 0.
Okay.
And so this one is like plus or minus 0. What do you know about adding 0 and subtracting 0?
It has no effect on the number.
Yeah, and so basically this one up here has two solutions, plus 3 or minus 3. This one here actually has just one solution because plus 0 and minus 0 are the same number. 0 is neither negative nor positive.
Okay.
X squared equals minus 1. What is x?
So that would be root of minus 1, but you can't get roots of a... Can you get roots of a minus? Yeah, no, you can't get roots of a minus number. So is it just root 1?
Basically, there's no solution.
Okay.
And so what this shows you is that this one here has two roots or solutions. This one here has one root or more accurately, one repeated root. And then this last one has no roots or no solutions. Okay. So what this shows you is if the square root part is greater than 0, you get two roots. If it is equal to 0, you get one root. And if it is less than 0, you get no roots.
Okay.
The bit in the square root. Okay. So let's solve this first one.
Okay, so x plus 2 squared is 20. Wait, so for the previous one, could I just write down what, just the stuff there? Sorry.
Okay.
Thanks. Yep, I got that, thank you.
Okay. So how would you solve this first one?
So x plus 2 squared is 25. So, yep, so then x plus 2 is just root of 25, which is 5, which is plus or minus 5.
Mm-hmm.
So then x is plus or minus 5 minus 2. So x is either 3 or minus 7.
That's it. And so there you see you have two solutions, two roots. How about the next one?
So x plus 2 squared is 0. So we know that it's definitely going to be having one root because it equals to 0, but x plus 2 equals 0 if we just get rid of the square root. So x is minus 2.
Mm-hmm. So that has one solution, one root. And the last one?
So x plus 2 squared is minus 9. So x plus 2 is the root of minus 9. And then x is therefore root of minus 9 minus 2, but that's not really a solution though.
Yeah, there is no root of a negative number, and so that one at the end has no solutions. And so there you can see, they'll talk about roots and solutions and things. There you can literally see the first one has 2 roots or solutions, literally 2 roots plus root 25 and minus root 25. The second one has 1 root, 1 solution. It's 1 repeated one, plus root 0 and minus root 0. And then the last one has no solutions.
Okay.
So that's just what that's about. So greater than 0, equal to 0, less than 0. Okay, so by completing the square, decide whether these quadratic equations have no roots, 2 roots, or 1 repeated root. So how could you do that for part A?
So x squared plus 6x equals 0. So x squared plus 6x plus 11 equals 0. So x plus 3, x plus 3 squared minus 3 squared plus 11, which is minus 3 equals 0. So then x plus 3 squared is 3. So x plus 3 is plus or minus the root of 3.
And so how many roots?
So that's 2 roots, I think.
Yeah, and that's all they asked for, so that you can stop there. I'm just trying to... How would you know if you're going to get 1 root?
It would be equal to 0. So.
And how would you know if you get no roots?
It would be less than 0.
Yeah, so the square bracket would be equal to a negative.
Okay.
So complete the square, find the roots for this. Insert form, show this has no real roots. So how can we show that B has no real roots?
Okay, so for B, show algebraically that it has no x squared minus 7x plus 13 equals 0. So then if we assume it has the roots, then you have x minus 3.5 squared in a bracket plus 3.5 squared.
No.
Is it
what is a minus times a minus?
Plus.
And so you will always have to do minus the thing squared.
Oh, right, okay. So, yeah, so minus... so minus 3.5 squared. And then plus 13. So that would be plus 25.25 equals 0. So x minus 3.5 is minus 25.25. So then we know x is minus 22.25. And we know that because it's a minus value and it's less than 0, it has no real roots.
Yeah. So cannot root a negative. Therefore, and it's a show question, so you just say what they said. So therefore, no real roots.
Okay.
And they say real roots because in A-level further maths you have imaginary numbers, and so that's it. A much easier way to do that question, but they didn't. I'm just going by the book. A much easier way is the quadratic formula.
Okay.
The square root bit has b squared minus 4ac in it.
Yeah.
And so if you just do b squared minus 4ac for the original thing, if you get an answer that's bigger than 0, it'll have 2 real roots. If you get an answer that's equal to 0, then it has 1 repeated root. And if you get an answer that's less than 0, you have no real roots.
Okay. So you use the b squared minus 4ac part.
Well, it's kind of ambiguous. So it's a new question for GCSE. In A-level, you only use what's called the discriminant, which is short for b squared minus 4ac. It seems like in the new one, they want you to show it by completing the square. So we've done what they asked, but you can see that this isn't a real past exam question. It's just what the book is saying is an exam style question.
Okay, yeah.
And it's because it hasn't previously come up. Okay, I can determine the number of roots that a quadratic has got.
I think that's a tick. Yeah, I got that. That's fine.
Okay, this is further maths only, but you're now doing further maths, so let's do it. What is this in completed square form?
So this is for further maths.
I think you're okay. So
Yeah.
in completed square form, x plus 2 squared minus 4 plus 11, that's plus 7? Okay, so if this was y equals,
Yeah.
so y equals this thing up here, and then down here, so y equals, we wrote the same thing in a similar form. If you have to find the minimum on the graph, or if you think about just the lowest possible value, if you have x is the input and x squared is the output, what's the lowest x squared you can get? So if you put in 3, you get 9. What's the lowest x squared you can get?
Is it so 3? Is it going to be 0?
Correct. It's because if you square a negative, you get a positive. So
Yeah.
the lowest thing is 0. So the minimum point or the lowest value you can get from this is when this square bracket is 0. So what x will make that square bracket 0?
Minus 2.
And when x is minus 2, what is the whole thing equal to? What is y equal to?
7.
And what that tells you is that if you were to draw this graph, it would be that usual quadratic graph. And that tells you that the coordinates of the minimum, the lowest point, are minus 2, 7. X is minus 2 and y is 7.
Okay, yeah.
So that's what that's about. Let me just see. So they want you to sketch this graph. Yeah, so they want you to sketch this graph.
Okay, so yeah, when they say sketch it, you don't have to it doesn't have to be exact or anything. It's just
It doesn't, so draw is when they want exact. Sketch is you just have to show the intercepts, and you have to get the quadrants correct. So you can't say that this one is plus over here if it's minus.
Okay, yeah.
Yeah, okay, so sketch the graph for this and do that by putting it into completed square form.
Okay. So sketch the graph. Okay, so that equals, so if we say y equals that, yeah, so then y equals x plus 3 squared, so x plus 3 squared minus 3 squared plus 11, so that will be minus 3. Oh no, plus 3, sorry.
Hold on, so minus 9 plus 11?
Yeah, plus 3, yeah.
And that'd be minus 9 plus 12?
Oh, sorry, so yeah, that'll be plus 2, sorry.
That's all right. Plus 2, okay, so the minimum?
So the minimum we know is going to be 0. So then if we replace x equals minus 3 to get that bracket to equal 0, and then if we do that, y would be equal to 2.
That's it.
So to sketch the graph, I just draw the parabola shape and then get it to minus. Yes, so then it will be minus 3, 2. So
what's the y-intercept?
2, like positive 2.
You get the y-intercept from this form up here.
Oh, plus 11.
That's it. Okay, so it goes through plus 11. The minimum point is minus 3 and 2 up. So let's say that's there. That's the lowest point on the graph. Okay. And so it's going to look something like that.
Okay, cool.
Yeah, any questions there?
No, I think I got that. That's fine.
Okay, so that's the only little extra bit that's in further maths that I thought I'd put in. Yeah, how'd you find that, Stefan?
I found that quite good. If you could email me the the slides maybe soon, so then I could just make sure I remember it all, if that's all right.
Yeah, that's okay. Any idea what you want to do next time?
I'm okay. Like whatever topic you think is good.
Okay, I think I might do something like algebraic fractions because it's like very difficult.
Okay.
Yeah, I'll email this to you now. Uh,
Cool.
any questions for me in general?
Yeah. So have you heard of the Hans Woida like maths, uh, like competition thing?
There's a few competitions. Yeah.
Yeah. Is it all right if I could email you maybe some questions,
Yeah.
for you as well, if that's okay?
Yeah.
Okay. You.
Yeah. Any other questions for me?
That's all. Thanks.
Okay. Well done, Stefan. You did great, and I look forward to talking again next week.
Okay. Speak to you next week then. Thank
All
you.
right. Have a good week. Goodbye.
Bye.